someplace in your documents there. 110. The best way I can describe it. We're going to create functions from words.
Okay.
It makes life simple.
So, word problems?
Well, they're not word problems because we're not solving for something. We're just creating functions to describe a situation.
Not word.
Okay.
The word is almost written.
What do they call it? Modeling with functions. Yeah, that's what they call it.
Sounds weird.
Creating or create functions from words, from an explanation of what's going on. So, to do this, we're going to do a couple different things. I don't like writing lots of words on the board. Skip. And Merry Christmas to every possible question, except for maybe 2 that will be on the test. Skip.
Can you tell us which two?
Well, I have to make 2 new ones, so
Okay.
I haven't made them yet.
This is skip.
These are the ones I just
Skip
skipped.
the problem.
Is this a quiz? Just don't.
No, don't worry about the title. I used to give out daily quizzes on paper, but now I do it on
Oh, good. Safe trees.
Sage trees, yeah. And it's easier to grade. It does it for me.
Safe trees.
It does it for me. So we're going to do these, but not exactly in the order that they're in. We're going to do number 5 first. Of course. Well, it randomly chose the wrong order, so I didn't care about that. So number 5 first.
Yay.
Now number 5 says, a farmer has, you're going to get sick of Mr. Farmer, by the way. A farmer has 4,500 feet of fencing materials. The farmer wants to enclose a rectangular area next to a river. The river side will not need fencing so that the cows can get to the water. Plus, you're assuming that your cows can't swim. Write a function for the area of the enclosure dependent on the length of the side parallel to the river. What is the natural realistic domain for this function? Okay. So, you have a river. And your fencing is rectangular in shape. Then you get that.
Shouldn't the river be blue?
Sorry, I didn't use my blue marker. This is the Tar River.
Oh.
It is definitely not blue.
It's brown.
Oh, clear.
The Tar River's not exactly.
I waited 3 years.
If you go up north, you actually see blue rivers and blue lakes. Down here, you don't see that. So, because this side is the parallel side, and also because it's parallel to the x-axis, you generally call this side x. You don't know the length of it. If you don't know the length of it, you just give it a variable. Do I know the length of this side? No, but because it's going vertically, I'm going to call it
Why?
y. Great. So I know something about this fence. It only has these 3 sides, and their dimensions are x by y. The only other thing I know about it is the farmer has 4,500 feet of fencing. That's all he has, 4,500 feet of fencing. This is called the farmer's constraint. He cannot make a huge fenced-in area other than using that much material. Can't use any more than that. So, what you're going to come up with first is what's called the constraint equation. So, what is the constraint equation according to this 4,500 feet of fencing and the dimensions of our rectangle over here?
I have no idea, but I think that you should know.
No, you should tell me.
What's a constraint? What's a constraint?
How much fencing went here?
X.
Y. How much went here?
X.
How much went here?
Y.
How much did I?
2y plus x equals
2y plus
45
x
seconds.
equals 4,500. So you get 2y plus x is equal to the 4,500 feet of fencing. So whatever values you choose for x and y, they cannot add up to more in this equation than 4,500. All right, that's why it's called a constraint. The other one is called an objective.
Right.
It's the other thing that we talk about in the problem. What's the other thing?
Water.
The river.
Nope.
Counts.
Has something to do with this rectangle.
Area.
Area. It says come up with a function of the area.
Yeah.
So what would be the area of this rectangle? X times y. The problem with area equals to x times y is right now it's what's called a multivariate function. And guess what? You do not want to work in those.
Wait, what?
This is the where like you solve for one of these.
Yeah, you be quiet over there.
Okay. It's substitution.
It is a substitution problem. The problem with this side is it has way too many variables. So I want to get rid of either x or get rid of y and write it in terms of the other one. To do that, you have to come back over here to the constraint. Which one is easier to solve for?
X.
And technically, the problem says write your function in terms of this side, the one that's parallel to the river. So I want to solve for x, and you get x is equal to 4,500
Minus 2y.
minus 2y. You take this piece and you plug it into that equation, where it belongs. So this becomes a of x is now equal to,
4,500y minus.
okay, you're really confused. What letters first?
X.
X.
4,500 minus 2y.
This one gets the 4,500 minus 2.
No,
It can't be
the
the
X,
x
the X
y
gets
because
it.
you're substituting for
Oh.
x.
X gets it.
Well, then we have a problem.
No, you don't.
If I substitute the x away, I have a function of,
2y squared.
I don't want y. I want
X.
x. So I got to go back and change that. So I don't want to solve
You
for,
just told us that would be
I was just going with you guys. I don't want to solve for x, I really want to solve for y. So you get 2y is equal to 4,500 minus x, then divide everything by 2. This is what I want to substitute into y. So you get a of x, that's what I really want, is that area in terms of x. Alright,
X.
leave the x there, I really wanted that x there, that's why I forced it to be there, times,
2250.
No,
well, you can write it that way,
minus
2250 minus
X halves.
x has, sure, 40, what was it again?
2250. We're gonna do. Can we just do it 4,500 minus x?
4,500 minus x all over 2.
Keep it very simple for small-minded people.
Keep it very simple, yes. We can do a little manipulation here. Pull the half out, so you don't have to look at it over there anymore. So a of x is equal to 1/2. I highly suggest you distribute the x. This becomes 4,500 x minus x squared. What does the graph of this thing look like?
Square.
It's a parabola. Which way is it facing?
Down.
Down, because it's negative x squared. What are the x-intercepts?
What are the x-intercepts?
One of. Oh wait.
Something. Set this equal to 0, solve for x.
0.
0 is one of them,
And then the other one is 4,500.
4,500. So on one side is 0, the other side is positive 4,500. Oh, Lord.
How do you
Oh wait,
get
no, never mind, got it.
if you set it together?
0 equals 1/2 4,500 x minus x squared. What would you do first to solve this equation?
Times everything by 2.
Multiply everything by 2. You get 0 equals 4,500 x minus x squared. How would you solve this equation? Factor out an x and you get x times the quantity 4,500 minus x. So this thing is equal to 0 when x is equal to 0. And when x is equal to 4,500.
Yeah, it would be 4,500.
Yeah.
Right? Yeah.
So the natural domain of this thing starts where? 0. Where does it end? 4,500. And I really shouldn't put brackets there. I really should put parentheses. Because if it ever equals 0, we don't get a rectangle. And if it ever equals 4,500, we don't get a rectangle. So technically it should be 0 to 4,500. Because remember, this is x. X is the side length of this side. If I make this side 4,500 feet, how much is left for y?
None.
None, so you just get a straight fence.
And the cows will
And if you make x equal to 0, then all the fencing goes into this direction, which would make a fence going this way 4,500 feet. 0 area. But what?
You should have thought about that before you bought cows.
You should have thought of that. He has area now. I mean, you just choose some
How
x
so-
other than those two.
These cows are going to drown.
Only if they
Cows
try.
can swim.
Cows can swim, I know.
Cows can swim.
Yeah.
Fat cows.
That cow.
They float.
Fat cows.
Same thing. I feel like
All right.
Chocolate cows make chocolate.
Very similar.
Nothing to do with swimming.
Number one.
All right.
So.
Very similar. Number one. That's it. That's all I
That's
want.
it.
Is the
Okay,
function.
hold on. Okay, so you wanted the function.
A function and its domain. There's nothing to do. Yet. That's next chapter. Okay.
Why would you multiply by 2?
To get rid of
To get rid of the 1 half. Get rid of the 1 half.
I think that 1/2. I don't like fractions.
So to get rid of fractions.
Multiply by the
Don't
common
add the
denominator.
whole. I'll explain it to you later. Multiply the whole thing.
Delayed reaction. Multiply by the common denominator. Number one.
She really does.
Hold on,
She doesn't deserve it. I'm high off meds right now.
We can tell. You're talking way too much.
Irregular.
A breeder needs to build a fence in a rectangular region that is divided in the middle. One side for male dogs, the other side for female dogs. You want to keep them separate so they don't create little puppies.
Yeah.
The area of the enclosure needs to be 450 square feet. Find the function of the perimeter, P of X, as of this enclosure dependent on the length of the long side. What is the natural, realistic domain for this function, P of X?
Okay, you read that so
Wait, yeah, can you read
The
that?
words are in front of you. You can follow along.
I got that.
So
I you just lost me. My eyes don't move that fast.
you got a rectangular thing that has a divider.
Right, I know that much.
Now each one of these black lines is fencing.
Right.
All right. We know that the area of this enclosure has to be
450.
450 square feet.
Wait, does that mean separately for each little box?
No, the whole enclosure is 450 square feet.
So can we split that in half? Or just one of them?
Don't bother. Stop making things harder. The whole enclosure area is 450 square feet. Now, the length of this side we're going to call X. Now, you could call this little one X and this little one X, and then the whole side becomes 2X, but what's the point? Call the whole thing X. Call this side Y. Great. Now, what is our constraint in this case? Is it the perimeter like this one?
No,
it's the middle,
it's
it's the
the
middle.
middle.
No, it's not the middle beam.
Area.
It's the division of the two.
It's an area. It's an area.
Why?
Because this is the only number I'm given. That has to be the constraint. So, how do you write the area of this shape in its formula? Area
XY.
equals xy, right? But I know what area is equal to. It's equal to 450. So I get 450 equals x times y. This is my constraint. I have to have an enclosure that has this exact area. Maybe there's some law in the city council here with to make sure these enclosures are a certain size. All right, my objective function, I want it in terms of x. So I need to take this equation and solve it for
Why?
y. If you want it in terms of x, you have to solve the constraint in the opposite variable. So what's y equal to? 450 divided by x.
What?
All right. What is the objective formula? It says in the problem that it's the perimeter function. I'll give you
So
that.
it's
P.
2x plus 2y.
Close, no cigar.
Huh?
X plus Y.
1.
Worse.
Wow.
What is it? No.
4 is what?
4
4y.
2y.
No.
3y.
Okay, ready?
Is it 3y?
How- Hold on. Along the base here, how far is that?
X.
How long across the top?
2x.
How many x's is that?
2x.
How far is it from here to here?
Y.
Here to here?
Oh,
Here to here?
3y. I said 3y minus 2x.
Not
Plus
minus.
2x.
So it's 2x plus
3y.
3y's. If you have to, sit there and go y, x, and then see how many there are.
Too lazy.
Too lazy. All right, I need to take this and plug it into this. So I'm going to get a perimeter function in terms of x is equal to 2x plus 3, and I know I have to get rid of the y. So if you solve that one wrong, you know you have to get rid of y. If you don't have y equals over there, just go back and solve for y. What goes here?
450
450 over x. So 3 times 450.
12.
What is it?
It's like
1350. 1350 over x. All right.
Wait, 3x.
Yeah, 1350 over x.
Oh, shut up.
Over 3. Are you distributing the 3 top and bottom of a fraction?
No, because that would be 1.
That's crazy. All right. Here's our function. What is the natural domain of this function? What is the smallest?
It can't be 0. It can't be 0.
It starts at 0, so the domain of this thing is going to start at 0.
Mm-hmm. But not included.
Yeah, I know. That's why I put a parentheses.
Oh,
150 maybe?
I know it. Yeah.
Infinity.
When in doubt, guess infinity.
Yes.
Because as x goes to infinity, this one goes to 0, which is kind of cool, and you're left with that answer over there. So this one says the perimeter can be, this side can be anywhere between 0 and infinity. That's only because we have to make up 450 square feet. Has to be a rectangle no matter what we do to this thing. So this side would get really, really small, and the other side would get really, really
Big.
small. It would be a very tiny number.
Tiny. Real little.
Yeah, as x gets bigger, you're dividing by a bigger number, therefore this thing just becomes nothing. And then all the number comes over here, times x. But that's the natural. What? Wow. Haven't even started. I got 5 problems to get through.
Oh my gosh.
Only
Actually, we only have 3 left.
3 left. We've done
Oh,
past 2.
dude.
How exciting.
Was not here yesterday. Quiz.
Yeah, you are.
Actually, it wasn't that hard.
Yeah, the quiz yesterday was pretty easy.
Now,
Yeah, you were
this
there.
is a small question
You didn't
about
have to
this.
make them up.
Why would you want to come up with this function? Well, actually, let's go back to the farmer over here. Why would you want a function of the area? What would the farmer want to do to the area with that
Fill
much
it.
fencing?
Fill it.
Yeah, but the area starts at 0, as a parabola goes up and then it comes back down. Where would you want the area? You want it at the maximum. This one here, you're building this thing with as much fence as you could possibly use. Notice you can go off to infinity. So what would this one want to do? Minimize it. It would want to minimize how much fencing you actually put in there to come up with 450. Now, the first one's easy. It's a parabola. You can maximize those pretty easy. This one's a little bit more tricky. It actually requires calculus to find the answer.
Yeah, we're good.
Hmm?
Good.
You don't want
No, I said it's
to.
good.
it.
Do it.
No,
No.
You don't want to see it.
I want to see it.
No, you
No.
They don't want to see it.
Aw.
You said it all
Sam,
night.
it's like 5 against. I have a feeling I'm gonna like cry in calculus. And I'm probably
Pretty much everybody does.
I'm probably gonna have to take it online.
Do not take it online.
Dude, Nick is doing great at it.
Thanks.
Yeah, but you don't learn anything. That's the sad thing.
You're forcing me to take it this summer. Nick,
I'm forcing you to take it this summer. So if anybody wants to take it this summer, same time slot, continue for the summer lesson.
Please, I don't want to be alone.
I don't care about baseball. Baseball's
Hey,
boring. I'm just joking.
will you be here?
yeah, what you mean?
I have like 3 camps. I have to go to leadership and I have to work.
Number 3, the hard one.
Why are we jumping around? It's annoying me.
Oh well. Number 3. A concert production team wants to know how much money can be made for an upcoming show. Previous concerts sold 5,500 tickets at $27 per ticket. An online survey of interested attendees found that for each increase of $7 in the ticket price, the number of tickets sold would decrease by 532, which makes sense. If the ticket prices go up, less people are willing to
Buy them.
Okay. Write a function f of x of the number of tickets sold dependent on the price. We'll get to the rest of it later. Alright, so far what we know is when the ticket price is $27, you can sell 5,500 tickets. When the price goes up $7. Your attendance goes down 532. What kind of function does this thing sound like?
Sounds like downward.
For every $7 increase, this thing is going down a consistent 532 people.
It sounds like
Linear.
Yeah.
It's definitely linear because it has a slope. There's a slope involved here. If you don't see the slope, set this up as coordinates. The first coordinate is 27, 5,500. The second coordinate, you could just make it up. You can either go A, up $7, or B,
let's do up 7.
down 7. Now, the reason I want to go down 7,
Down 7 then.
because this
So
makes it
bring it to
nice
20.
20. Yeah. So this would be 20. If this went down 7, this would go up 532, so that would be 6,032. So these are 2 points on a linear graph. Now I want to create a function out of this linear graph. So how do I create the equation of a line?
You put it into a calculator.
No.
You do
What do I have to find first?
the slope.
The slope. So
Something
change
That's what you do.
in the number of people over the change in X, which is our price. The change in number of people over the change in the price. Stop it. So, the change in the number of people, depending on which way you go, I'm going to go this way. That would be 532. If I go this way, negative 7. So this is, I don't know, does 7 go into 532?
76.
Ah, good. Negative 76. Very nice. Alright, now what?
Now we have to put into MX plus B.
N is just the number of people that attend to the concert. So this would be changing the number of people between these two numbers.
We could do MX plus B.
I don't do MX plus B to find the equation of a line.
It's really hot.
What?
It's really hot.
Are you
Close
still
the door.
sick? The
Yes,
formula you
she's
should
still
use,
Oh, yeah.
this one.
Okay. If I get sick, I'm blaming
You could always move.
Yeah, just move.
I knew that was coming. Alright, so which one do you want to use for Y1 and X1?
I
Choose
think
top
20 and
Top one. Alright. So Y minus
Y
5,500 is equal to negative 76. X minus 27. So anytime you're given a goes up, goes down type of thing, it's usually linear. Alright, solve for Y.
Probably multiplied with 76.
More than likely.
No doubt.
And then you
So what's 76 times 27?
Something big.
2052.
Yep. Like I
52.
That's a big number.
Yeah, that's a big number. And then add across 5,500. So Y equals negative 76x plus 7552.
Yeah.
Alright, did I tell you what to call this function?
You didn't
No.
Yes, I did. Write a function f of x. So this actually gets turned into f of x is equal to negative 76x plus 7552. Highly suggest you check one of your, which one?
2. Okay. Where are you talking about that?
I'm really worried now.
2052, Chelsea. Can you make your 20s consistent? I mean your 2s consistent.
I know, I run them two different ways. I can get two,
Yeah, make them
two.
consistent.
Depends on which
Should work
side
on
I'm standing on.
Oh, I just noticed that.
Check one of your points. Take 20, plug it into your function, and see if you get 6032 out of it. So, negative 76 times 20 plus 7552. Make sure it works.
76 times 20 is
You don't have a calculator.
No,
2,
listen.
here's
I don't know if you're asking.
1,
Yeah, that's right.
It's right.
5, 15, 20.
Alright. Second part of the equation. Woo. So, this is the number.
I'm sorry.
No, I'm saying like this is.
15, 20.
crazy.
Means
Unless I'm being a
7.5
construction worker, I can give it 2 cents
20.
like this.
I know. Isn't that horrible?
Yes.
Hey, I got the mental math right.
You're mental.
Thank you.
Okay. Second part. It says.
I have no room.
Also write a function g of x for the amount of money generated by ticket sales based on the ticket price in f of x. So, how do you find,
Quiz is gonna suck on this.
What?
Yeah,
What is
kinda.
it?
how do you find the net income from this concert?
I don't remember
Probably
any of
we
you
did
did
that
that.
and then multiply by the number of people.
The net income?
I'm waiting for
Number.
that. Huge.
Net income?
Net income. How much money did this concert generate? Guys,
Wait, what's the question?
how much money is this concert going to generate? Now remember, x is your ticket price,
So we gotta do 27.
and f of x is how many people are coming to your concert. So, if your ticket price is $5 and 100 people show up,
500.
$500, right?
Yeah.
So you take your ticket price and you multiply by
Something.
The people.
how many people came to the concert. So g of x is going to equal,
But either way, you're still
what's the ticket price?
100.
No. What's the ticket price? X.
27.
How many people showed up to the concert?
Why? Well, no.
I thought X was the number of people that.
X is the ticket
What
price.
did you say? Why
Don't
does
we
it
know
say
the ticket
27?
price? The ticket price is 7.
It was 27 per ticket.
That's 27.
Okay. Come back over here.
27 plus 7.
Originally, the ticket price was $27. They would sell 5,500 tickets. If they increase the price of the tickets, they lose this many people. What they want to do eventually is maximize how much money's coming in.
Yeah.
So to find that out, they want to set the ticket price properly. This is not a guaranteed price. This is what they did last time. So they're thinking if they increase the price, they might be able to make a little bit more moolah. So x is the price of the ticket. F of x is
Number two is
the number of tickets sold. So g of x is going to equal the price of the ticket times f of x. This is the same thing as money per person times persons. What happens to the
People
persons?
that cancel out.
And you get it with cash. So g of x is going to equal
So lost.
where?
Everywhere.
Probably because you were talking through half of it.
I
I
was
was paying attention.
So in a way.
So x times f of x is x times this mess. So it becomes negative 76 x squared plus 7552 x.
Because it's F. You gotta remember the X in it.
Yeah, if you multiply this by x.
I get it now.
You get it now. What kind of graph this is?
It's a parabola.
It's a parabola. So it has a general setup. It starts here, goes up, comes back down, and hits over here. Where does it hit? I know, but specifically, I need the domain of this thing. So I know it starts at 0. How do I find this point?
I don't know. Oh, you said everything equal to 0.
Set it equal to 0. Factor out the x. What you're left with is 7552 and
76.
this negative 76x. So it's basically 7552 divided by.
76.
Wait, what? I'm so confused.
And
Where are you?
How did you get the function?
It's gonna be
Oh,
like
this
9.
function?
Yes.
It is the price per person that you're charging for the tickets times the number of people that went to the show.
It's like 90 something.
What the price per person is
70.
x. No, we called it x over there. And the number of people that showed up for the show is this function that we came up with, f of x. So if you multiply those two together, you get this.
multiply.
It's 99.
Oh,
What is it?
okay.
99.36.
I told you I was 90 something.
99.36.
Wait.
So
Are
if you charge $0 for your tickets, you're not going to get anybody, which I doubt, but maybe they think it's a stupid concert if you're giving away tickets for free. And over here on the other side of the spectrum, if you charge $99 per ticket, nobody's going to go.
Yeah, right.
So the price that you want to set it at is
Middle.
actually halfway between those two.
So 99
It would be
minus.
like
It would be like 40.
It's about $50. 40.
49.
Oh,
You're
yeah.
really gonna figure out the math.
Only 46.
49.
$50.
50.
Make it $50 and you'll be safe.
49.68.
Told you.
They said that
69
if they raise it $7, then 530, like.
They lose some people, yeah.
So if they raise it $50, then like they will lose more people.
Not, we're not raising it $50. We're setting the price at $50.
So isn't it already 27?
It's already 27, but if you raise it to $50, you bring in more money. Your number of people that show up are less, but you bring in more money.
That's what they want.
And then that's what that's what.
So if you put like $1, not many people.
Right.
Why?
It's just the way this model sets up. Models are not perfect models of the world.
So when you set up 50, that brings in the money. That's what you're saying.
Yeah, if this was a calculus class, you'd go for that maximum profit.
Go for gold.
Go for the gold.
Wait, so what's the answer, second answer?
The answer's right here.
Right there.
Okay, that's it.
And this is f of x over here.
What number are we doing next? 4 or 2?
What number are we doing next?
Is it quiz time?
Yes.
We have to
Is it
have
Miller
it
time?
all.
Middle light.
Can we get some water?
It's
Go.
time.
Who said, can I have some water?
Chelsea.
Chelsea, go get some water.
I think you're higher.
It's not like high school. Leave if you want to leave.
4 falls.
Just don't come back. Just kidding.
Oh, you're in.
Don't
I don't need the chair.
Don't get her over.
So, continue 110. What about if I have a triangle? Oops, missed it. Such that this coordinate here is 6, 8. It's an equilateral triangle, so this coordinate over here is negative 6, 8, if you really want to know.
Is that 0, 0?
This is 0, 0. I just kind of missed it on my drawing. So it's an equilateral triangle. Another famous thing that calculus does is they want to come up with a function of the area of the triangle formed by a line that is moving up the y-axis. And it's constantly moving, so you can't just call it a specific number. So we're going to cut this thing like here, and we're going to call this height y. How do I find the area of the green triangle according to the height y? This is y, and I want the area of the big green triangle.
Is it mid, like?
It's not midway, it's anywhere between 0 and 8. So y is on the interval 0 to 8, somewhere in there. Ah, 8, not infinity. What's that? Parts of it, you know, it depends on how you want to look at it. So how do you find the area of the big black triangle?
You found the distance and then
1/2. You do the mid.
No, it's 1/2 base times height, so you go area equals 1/2 base times height. What's the base of that big black triangle?
12.
It's 12, right? It's 6 this direction and it's 6 that direction, so that would be 12. What's its height? 8. So the area of the big triangle is 48.
You just subtract the two areas, don't you?
yeah, it's
Or
40.
you just subtract them?
What do you mean subtract?
I'm talking about.
Oh no, I don't want the trapezoid area. I just want the triangle.
Oh, okay.
I just want the triangle. So my problem is this. I know the height. The height is going to be y. So when I set up that one, it's going to be area equals 1/2. I don't know what the base is, so I'll leave it as b. But the height is y. What I need is the base in terms of y.
What's that first thing you wrote down?
Oh, that?
Big triangle.
This guy? Get rid of that.
I don't know. What is it though?
What is what?
That.
This piece?
Yes.
Y, the height of this, is only between 0 and 8. It starts at 0, stops at 8. 8 high. 8 high. The scribble out was me writing infinity, thinking it was 8. Go figure, I'm so used to writing infinity in there. Alright, so how am I going to find the base of this green triangle according to its height y? Any suggestions?
You can use the slope.
I can use the slope. I can come up with the equation of a line. This line right here. If I know the equation of this line, each one of the points is an x and a y. The y will be how high up, the x will be how far over. So how do I find the equation of that line?
Point slope y.
What's the slope?
8/6.
8 over 6, right? Reduces to 4/3. What would be the equation of that line going through 6/8?
Y minus
Y equals 4/3 x. Y, the intercept is 0, 0, so we don't have to worry about that. So what's the length of this side right here then? In terms of y. Now this is x, right? Because this would be the coordinate x, y. But I know the height is y. What's this length then? Well, y equals 4/3 x. I need to solve for, how do I solve for x?
You said 0, you said 1. No, you.
In this equation, how do you solve for x?
So what?
Plug in.
Yeah, you don't switch them. It's not inverse
So
function.
y
Multiply both sides by
3.
3/4. So you get x equals 3/4 of y. Oy. All right. For those that are not comfortable with the algebra of that, let's do the geometric way of doing it. Geometric way. Here's your big triangle. Here's your little triangle. This side is y. How high is this thing? 8. This side is x. This side is 6. What kind of triangles are the big black one and the little green one? What are they called?
Right triangle.
They're both right triangles.
But they're
They're
similar.
not congruent. They're similar. What's true about similar triangles and their
They
sides?
have this. They have the same angles.
Angles
Their
are great.
angles are congruent.
I'm more
Their
interested in the
sides
sides.
Their sides are proportional.
Sides are proportional. So if the sides are proportional, if you set up 6 over 8, what's it equal to?
X over y.
X over y. And if you solve this thing for x,
It would be 6y equals 8x.
which is the same thing as 3/4 y is equal to x, which gives you the exact same thing. So whether you do proportional with triangles or a line equation, both of them come up with the same thing.
Do we just solve it?
Solve what?
I don't know.
I'm coming up with the function of the area of the green triangle depending on how deep it is. Does that make sense?
Sure.
Okay. So I can change my function now into area equals 1/2. What's my b now?
3/4 y.
3/4 y, because that's what x is equal to. This would be 3/4 y times y. So the area of that triangle is always going to be 3/8 y squared.
Wait, 3/8? Don't you mean? Oh, never mind. Josh.
Were you going to multiply? Never mind. I don't even want to.
No, I just don't know.
So that's the area.
That's the area of that triangle. Ooh, I made one mistake. What mistake? I love making mistakes and having you find them.
Does it have to be a?
Sure, x is equal to 3/4 y. But that goes from here to here.
That's
Oh,
only half
you
of it.
gotta
That's only
times
half of
by
it.
Divide by 2.
I got times it by 2, so it's 2 times that. So this would be
It would be 3/4 y squared.
3/4 y squared. Yeah, that's better.
I like that.
Now, you're going to need this to do number 70. This is a 2-dimensional idea. 70 is a 3-dimensional idea. But it does the exact same thing.
Wait, so what?
Do you want me to do it one more?
Yeah.
Very similar.
Sarcastic.
Not construction work.
Let's go backwards.
Oh, it's being sarcastic.
I wasn't.
What?
I'm usually sarcastic, so I'm wondering. I want to find the area of the trapezoid.
Wait, what was the answer?
This is where you go out to subtract.
What was the answer to the first one?
The answer to the first one is this. A equals 3/4 y squared.
The X is confusing.
No, but why? I don't understand.
Because area is equal to 1/2 base times height. The height was y. the base was literally 2 times x.
Yeah.
X in this direction, x in that direction. So we came up with the equation of the line, solved it for x. So when we're given y, I know how big x is. So I just took this and multiplied it by 2 and put it in for base.
So 2 times
2 times 3/4 y gives you 2 x's. So that gets plugged in here. So this is your base, this is your height, and that's half of it for a triangle. All right, if this is y, that's my height. How do I find the area of the trapezoid, given that this coordinate up here is, let's make it 0, 10. And this coordinate over here is 5, 0, and this one is, yeah, I guess. That'll work.
That
Wanna be
that
negative
would be
five?
negative
Ah.
5, 0.
Oopsie.
Dyslexia. Gotta love it.
Make me happy.
I have it.
So, what do I need for the area of a trapezoid?
You can split it up into 2
No, stop that. How do you find the area of a...
That's
Well,
the
it's-
equation.
One half.
It's height and base.
Yeah, base 1, base 2, what
Base.
else?
And height.
And the height. So it's 1/2 the height times base 1 plus base 2. Basically, it's the average of the bases times height. Average of the bases times height. All right, we know the height.
Why?
It's y. That's easy.
Alright.
So this is so far a equals 1/2 y. We know one of the bases. Yeah.
10.
This is 10.
Mm-hmm.
5 to here, 5 to there, so that would be 10. So the only other one is that other b, that top
We'll call
base. The top base.
We'll call it
So call it
X.
x here, x there, because it's x units to the left and it's x units to the right. So again, I need y to be x in terms of my y variable. So find the relationship. You can either A, use similar triangles, or B, use an equation of a line. Which one's easier? You like the equation of a line? I like similar triangles, but that's just me. So the equation of this line is what? What's its slope?
I like similar triangles.
So do I, but too bad. What's changing y over changing x?
Negative 10 over 5.
Negative 10 over 5, better known as negative 2.
And that would be
Y minus,
Why not?
What?
you gotta do y minus y sub 1 equals m times.
Wait, can you start over from why you did change and why change?
They're going to find the equation of this line. Equation of that line segment. So the first thing you do is you do 10 minus 0, 0 minus 5. That gives you the negative 2. And then you have to use one of the coordinates. Now, you either use 5, 0 or you use 0, 10.
10.
I'd use 10 because it's a y-intercept. So y minus 10 equals negative 2 times x minus 0, but it basically is just negative 2x. Move the 10 across and you get y equals negative 2x plus 10. And this is good review too, because I'm going to ask you to find equations of lines. All right, what do I want to do with this equation so I can work with this one?
Solve it for x.
Solve it for x. So how do you solve for x?
Minus 10 over
Minus 10 and divide by
2.
a negative 2. So this is going to become, I'll let you think about it.
Negative 1/2 y plus 5.
Yeah, you could write it that way too if you want, but I like that one better. So this equals x. Subtract 10, divide by negative 2, you're all set. So if this is equal to x, remember that only goes from here to here. So I have to multiply that by
2.
And it becomes
10 minus y.
10 minus y. So this becomes 10 minus y.
How did you get y minus 10 equals negative 2?
This?
No.
This. Different color. Y minus y sub 1 equals m times x minus x sub 1. Equation of a line. The slope is
Negative
negative 2, the point I'm using is 0, 10. So it becomes y minus 10 and x minus 0.
So isn't that all point numbers?
No, you could use this one. And it'll come out the exact same answer.
Why did you, when you plugged it in, why did you do away with the 2 on the bottom?
Oh, because this x is only going from the y-axis to the curve, to the line. But there's 2 of them.
Okay.
So I multiplied that by 2. Does that make sense? Okay. And then simplify this thing, and you get a equals a half, 10 plus 10? That'd be 20, so you get y, 20 minus y.
And then, what'd you say?
I'd leave it like that, but you could distribute if you want. You know, it'd be 1/2, well, 10y minus 1/2 y squared. Ah. How about this one? This was actually in the New York Times. A physicist was playing catch with his dog in the snow, and the sidewalk was cleared, and there was snow on the left, and he would throw the ball into the snow. The dog would take off down the sidewalk and then cut over to get to the ball. And he did some calculations, and he found out that the dog did it in the shortest time possible. It's kind of cool. So this problem works out this way. If you're on a road, Vegas, and you can go a certain speed on the road, but this road is right next to water, so this is water over here.
We're doing a cow kind of thing here.
And over here is an island, and your car is really fancy. It can go into water. It's one of those boat cars.
James Bond.
James Bond type car, yeah. So the road's going to keep going, and the distance to the island is 5 miles. Well,
Let's make it 10.
It's way out there.
yeah, let's just do miles. 5 miles. Doesn't have to be quite that far. And what you want to do is you want to drive, starting from here, you want to drive as fast as you can to get to this island. But you have to get to the island. So you have a choice. You can go all the way down perpendicular to the island and travel to it. Obviously, that one's going to take you
The longest.
the longest.
Yeah.
Or you could start your, actually this would take you the longest. You could jump right in the water and go right to the island. That would take you the longest.
Especially with the water.
Or you could find someplace on the shore to cut over. So let's say the distance between here and here is 10 miles. The distance between this point and here, of course, is 5 miles. So, how far did he travel on the straightaway? Well, we don't know what this distance is, so you either choose this as x or this as x. Which one do you think will be easier?
The
dotted
dotted
line.
The dotted line. Call this one x. Call this one
10 minus
10 minus x. Don't do x minus 10, it'll give you negative answers. All right, if this is x and this is 5, what's the length of this side?
25 plus x squared. Oh, it's square root of
square root.
Yeah, so this would be the square root of x squared plus 25, or 25 plus x squared. I could care less which way you write it. Okay, so let's say on the road, he can do 90 miles per hour. Really, really fast. But in the water, he can only do 25 miles per hour.
wow.
Should have said he can go underwater.
I should have just called it travel time, length of travel time. That doesn't make any sense. Find t, the travel time. In terms of this x that we chose. In other words, where should we jump off this road will determine how long it takes us to get to the island. All right. So if he can do 90 miles per hour and 25 miles per hour, what does that have to do with how long it takes him to get there? What formula kicks in when I give you speed and distances?
The average rate.
Oh, please don't get into physics. Simple formula. You're driving at 50 miles per hour and you drive for 3 hours. How far do you go?
Distance.
Distance equals
Time.
time. Holy crap. If you're driving at 50 miles per hour rate for 3 hours, time, how far do you go?
150
Distance.
miles.
150 miles. So what do you do to those two quantities?
You multiply.
You multiply them.
Time and distance.
So, distance equals rate times time. Distance equals rate times time. But I've only given you distance and rate. I want time by itself, so what do I have to solve for?
R equals T.
Right, so I get t is equal to the distance divided by the rate. So if you drove 150 miles at 50 miles per hour, it would take you 3 hours. Okay, so how long did he spend on the 10 minus x part of the road? 10 minus x over 90. How much time did he spend on the square root of x squared plus 25?
X squared plus 25. How did you get that number?
Which one?
X squared. I mean, Pythagorean.
Pythagorean theorem. If this side is 5 and this side is x, since this is a right triangle, it's x squared plus 5 squared, all square root.
Is X water?
X water? No, x is if you kept traveling straight.
I know, I'm asking if it's road or water.
No, it's road.
Okay.
The water is out here on this side. This is water. Over here. I'll draw a better picture next time. So this will be how much time according to when he jumps off. Now, if you're James Bond and you want to get to the island the fastest, what do you want this thing to do?
Take the least amount of time.
Take the least amount of time, so you'd want to minimize that function. But we're not going to do that because that requires calculus.
Do it.
Ah.
No.